Hey listeners, Omar's connectivity was not the best during this recording. I've done my best to clean it up, but you still may notice a little bit of weirdness. Thanks for bearing with us. Enjoy the show.
But I think it does help to have that mindset. And once you have that mindset, you can train other people in your team or organization and focus them around what are the people that we're working with caring about.
Welcome to the LabVIEW experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. I am here today with Omar Mussa, and you may know Omar used to work at JKI, and then you worked at Virgin Orbit for a while, right?
Mhm.
And you're doing some other rocket stuff now. Is that
I'm working for Stratolaunch. They're doing hypersonic vehicle research and
okay?
testing.
So yeah, aerospace, kind of cool stuff. And the big topic that Omar brought up that I really want to talk about that I think is important is how do we measure value? So there's all this talk in agile circles of delivering value to customers and continuous value delivery and all this stuff. And it's one of those things that I think is really hard to quantify and really hard to talk about. So I don't know if you have any thoughts on that, but I thought that would be a good place.
Yeah. So actually, I'll give credit where it's due. I think this is an area where I got my first real training and background in it when working at JKI as a consultant, like, a while ago now. Um, and Jim was really a big fan of thinking about value and customer value and continuous delivery of value over other things. And that kind of has stayed with me for my career, I guess. And um, what I would say is that it's definitely a subjective area, like what is valuable to people. In some cases, value equals a technical achievement. Um, but in other areas, value is also more qualitative, like having a person you can rely on, um, having basically yeah, reliability of the relationship on top of the technicals and on top of basically aligning and understanding what actually matters. And so for customers in different stages, what matters can evolve. Like if you're in a startup, your next deliverable, like the thing you care about might be based on trying to get, the next round of funding or whatever it might be. And so delivering value is aligning your tasks to hit that milestone and help deliver like whatever it takes to get that funding. And it may not be full technical success. It actually, in a lot of those kind of startup situations, the technical success isn't expected, but showing that you're on a path to create success is more important. And in other cases, it is just straight up, we need a prototype to work, and everything you can do to build that prototype is where you're delivering value. Um, for my cases now, like value is definitely more distributed. Like I have um, stakeholders within my organization that are caring about technical deliveries, but are also caring about efficiencies and can we make our test process more efficient and the value we can deliver by, for example, like minimizing how much testing we do offsite at other vendors and things. In some cases, there are actual easy to use metrics for like the difference in cost or whatever. But in other cases, I really do think delivering value has a lot to do with just understanding what your customer wants, and you have to ask them what they want, and the customer might be internal or remote. Understanding what their asks are, and then how do you align to that ask?
Yeah, so
I hope that makes sense.
it's
It's very,
like
well,
quantitative, something being quantitative, being able to measure it easily makes it a lot easier to kind of do that ranking and make decisions. Does that?
mhm. Yeah, and so yeah, so how do you convert from that qualitative to quantitative? I mean, I think one of the ways people are doing it typically is and it sounds funny, but like basically through Agile, like I think most of the people are that I know, so like task tracking and basically converting that qualitative ask into specific tasks that you can track and deliver against.
Mhm.
Um, and that does actually show progress and helps, people understand that you're moving in the direction that they've wanted you to move in. Other honest ways are basically hitting schedule milestones and like finding ways to ensure that you actually stay on schedule and manage schedule risk. That's really important too. And I think that um, that's an area where you can usually um, help deliver like you've already defined the scheduled targets in theory baked into that are value decisions like I need this by a certain date because it helps us enable blah blah blah. And so if you are able to help track and mitigate that schedule risk so that you hit that date, you actually also are delivering value in a way by definition. Um, so you're so those are other like quantitative ways, I guess. Um,
So I have a question.
sure.
The task tracking. So I personally have a problem. Like to-do lists are great, but I kind of hate them because I am the person that will check off all the easy boxes and push all the hard stuff down. Do you have a
Hmm.
way to like to kind of counteract that tendency to want to just check the box as opposed to like prioritizing things? And sometimes, maybe there's something that's high priority, but like it takes longer. And so therefore, like, oh, I can check off this one high priority box or I can check off four low priority boxes. And
Yeah,
my metric
that
went up because now I've checked off more boxes. And it's like, well, okay, but
yeah, gaming the systems to try to like show you're delivering value by closing more tickets and things. Usually that's an outcome of bad management in my mind. If you make metrics like that, like how many tickets you've closed, be the thing that is defining success, then people will game it and will find ways to create a lot of tickets that they close. Um, I think I think for those bigger questions, like how do you make sure that the big complicated technical task gets worked on and makes progress and actually like gets closed out? I honestly I find it to be a continuous challenge. Like it's not something that I have an answer for. Like right now in my existing role, I have probably three or four different ways I'm trying to track that. And in the way that means maybe my process is broken too. But I will say like, what ends up happening, especially in immature organizations, is that there aren't established, processes or tools for figuring out what matters. So it's up to individual like technical leaders and contributors to help define what that milestone and roadmap should look like and how to achieve whatever that target is. So that's largely what I how I get involved in my current role. And I can say that, between different tools like Smartsheet and Jira and, notes on just a bit effectively like a notepad or whatever you want to call it, like scratch pads, OneNote, whatever, information gets distributed really quickly across a lot of different sources and email and other things. And so being able as a technical leader to figure out which of those things matter and how to filter the signal from the noise is important. Um, what I've found matters is trying to figure out what the hardest thing you need to do is, and then making sure you're working on that continuously so that you basically close out the hardest part.
limiting the risk, right?
Yeah, exactly. Limiting risk and managing that. And usually, the other thing that I'm finding continuous as a continuous education for myself as well is that it's easy to get focused on the things you're good at. So I'm better, I'll say, at like software than say hardware related app tasks or other tasks. And so I tend to focus on what software tasks might be blocking us. Um, Whereas the projects that I'm working on are system level development type projects. And so the real blocker might actually be something in the hardware development or other unexpected schedule risk, like like long lead time items that have to arrive and that you may not really be able to understand until you receive them. Like manuals are great, documentation is great, but usually when you actually work with something and put it into the system, that's when you finally figure out what it didn't document and how it doesn't exactly work the way you expected. And you have to have, time in your schedule to and planning to basically accommodate that risk. Um, and that sort of unknown.
Yeah, that's the real learning by doing part.
Yeah. And so anyway, so I found that like a lot of these areas are easy for me to forget. Like in our case, let's say we need to do a vibration test. I'm really focused on making sure the software can acquire the data really well. I may not be as aware that, hey, we also need harnesses and we need adapter plates and other mounting hardware and things of that nature. And luckily, other people on my team are really good at looking ahead on those areas, and that's their strength. And so that's why it takes a village to do these kinds of big integrated tests. And you need to be aware of where if you're managing these kinds of projects, you have to be aware of where your limitations are and where you might be overly focused. So I try to be conscious of the fact that I don't always pay attention to those, I'll just say non-software aspects.
So does that go into the whole idea coming from like Agile or XP of like cross-functional teams, or you try to have
Yeah,
different skill sets so that hopefully there's some overlap?
for sure. I definitely think when you're doing system level development, and in this case, systems can be test systems. They don't have to be a product in and of themselves. Um, you definitely the diversity of ideas and diversity of engineering backgrounds and all these different aspects do matter and do play into having a successful team.
So I have another question. We kind of talked about metrics earlier and how some of them are easy to game.
Hmm.
Worth keeping track of some of those things? Because I've always thought that like keeping track of like number of tickets closed or something. Like, yes, that should not be your target, but sometimes it's a good indicator. Like if the number of tickets getting closed suddenly goes way down, I
Yeah.
think that's worth investigating. And maybe you just determine that like, hey, they worked on one really hard ticket that was really important and it took longer and okay. But sometimes
Yeah.
we find out that like, hey, so and so has been busy doing this other thing that we didn't know about or pulled in a different direction or
Yeah. And I also think that a lot of times if you work on one really big one ticket for a really long time, it usually means that that ticket should have been broken up into subtasks, and you just haven't done a good job of identifying those subtasks. And so your high level task is sort of stretching to the right, and it's mostly because you didn't understand the scope of all the things that go into that task. And um, you
so
hopefully can course correct as you go, but sometimes you have to learn that the other way, the hard way. Another metric though, and okay, closing tickets is good. Another way that I've actually tried to focus on for my team specifically right now, um, is how many. So as we do testing for these aerospace type cases that we're testing, 100 plus hours per unit in a lot of cases. Um, one of the things that happens inevitably in our test process is that we have discrepancies come up. Maybe the unit didn't work as expected, or maybe the software didn't, you know, had limits that were too tight or bugged out, or you had some random unexpected event that probably was mitigatable, but you didn't, have it in your procedure, like a Windows update happened to run in the middle of your test because it was so long, things like that. So one of the ways that I actually also try to track progress is how many discrepancies we open over time. And my goal is to open fewer per test. So in a way, you can also the absence of issues is also a way to track. So it's kind of a weird thing because it's harder to quantify, but you can do it over time if you've got enough data. You can say, hey, like in the first quarter or first year, first iteration of this project, we opened 10 test campaign and now we're at 8. And that's actually an important way you can track that you're improving. And a lot of times that that metric is what drives the length of, how long it takes to also generate your reports and do other things. So it'll actually, if you can reduce how many things go wrong, you can also, in general, streamline your process overall.
Yeah, I think that's one of the goals of the whole agile thing and that TDD
Yeah,
and CI/CD and all that is catching a lot of those problems earlier and preventing them from making it into production.
yeah,
So,
for sure. And a lot of the things that are in Agile in sort of there's different Agile like as a software development framework and Agile as a project management framework and now Agile as a hardware development framework. I feel like the most important parts to me of Agile are trying to do small incremental change very fast as opposed to doing large change very slow. And one of the other aspects that I personally care a lot about is the unit testing aspect, whether it's software or hardware, finding ways to compartmentalize what you're actually doing and testing it frequently and ideally maintaining that test product so that you can use it over and over again.
yeah, so I do want to make a comment of that because I was going to go back to the thing that we said earlier about if your task takes too long, you haven't broken it down. That to
Hmm.
me is the number one biggest problem that I see LabVIEW teams making is they try to take too big a step. And I think
Yeah,
it's just like too risky. But also, I think you mentioned Agile is about taking small iterative steps and quickly.
yeah.
I think part of that is it's the speed of feedback and the speed of learning. Because Agile is all about being able to change direction, but in order to change direction, you need to learn about the problem.
Hmm.
And so I think to your point, like you read the manuals and all that, and you think you have an idea of how it works, but when you actually get the piece of hardware and you start interacting with it, you realize there's all these things that they didn't put in the documentation or that don't come out. And so
Yeah.
to me, it's all about, if I had to sum up Agile, it's about learning and feedback and trying to
Yeah.
do that as quickly as possible. And the unit tests, I think, also kind of play into that of like learning that, like, when I change this thing, I don't break everything, or I do break this thing over there, and then I gotta go figure out why. And that learning process of figuring out, well, why does this thing over here change that? Oh, because there's some flaw in my design that these two things are coupled and they shouldn't be. That's useful information. Then you can take that and go change your design so they're no longer coupled.
And I also think that unit tests, so and I'm not thinking of it strictly from like a test-driven development perspective because I found that it's very hard to get teams to try to commit to test-driven development. And there's in a lot of cases good reasons for that. But honestly, like the other aspect of it is that you at least maintain this artifact that shows, hey, I validated this and it should work based on this test. And I've got in the unit test itself effectively a code as documentation and also as evidence that hey, this should work. And then later when you make other changes and if you inadvertently break a unit test, that is where the unit test creates the most value because all of a sudden you realize, hey, I broke this thing inadvertently. That shouldn't have happened. And I can go and fix my problem, hopefully, before I break the entire system or try it in a bigger way, whatever.
Yeah, I'm a big fan of the unit tests as documentation. So if, for example, I find some random open source project on GitHub or something that I want to use and I download it, one of the first things I look for is the test. Because A, I want to make sure that it is tested because I want to know, like, can I rely on this?
Yeah,
But B, looking at the tests, if they're well written, usually it's a high level, this is how it's expected to be used. This is the input that gets you this output. And then you can be like, okay, cool. My input's similar to this. I should get a similar output. And it's just kind of like, and maybe like, for example, like, I don't know, Dr. Powell's JSON stuff. You see how in the test he uses a series of calls in a row, and you're like, oh, that's how those three or four BIs are supposed to interact.
exactly. They're acting as an example as well
Yep.
as giving you an artifact of information that, hey, this actually works. Yep.
Yes,
So
it's like feeding two birds with one stone, or whatever the saying is. Or
yeah,
yeah,
exactly. And then in the virtuous cycle world, you integrate that in a continuous integration process and you get it for free at that point every time you do a future commit or future build, whatever it is. So that's
yeah,
the,
I'm actually quite. I'm very happy that when I started, right, when I started, Fab was still going around trying to get people to use any sort of source code control, and that was kind of the thing. I feel
oh
like
yeah,
now we've all agreed on that, and now I feel like the big push is to get everyone on some sort of CI/CD type pipeline. And I don't know. My feeling is that the people who are loud about it are probably the people who are doing it, and there's probably a large, and they're very vocal, and there's probably a large majority of people who aren't doing it. But I see more and more people
yeah,
doing it, or at least expressing interest, and that's really good.
yeah.
I'm super
I
excited about
think part of it too is that the community has evolved. I mean, LabVIEW as a community has always been rooted in non-computer science engineering. for the most part. So there are computer science people that get excited and get into LabVIEW, and I'm grateful for that. But a lot of the people that use LabVIEW are electrical engineers or mechanical engineers or maybe not engineers at all. And it's really important that the the tools and the processes that make software engineering possible are easy to adapt and to adopt inside of LabVIEW. And so, I mean, I think JKI was an instrumental group to help support that initially, and I think other groups have now helped in Hample Engineering and other Hamplesoft, and others have done such a great job of helping show the path forward. And now, NI is very publicly on board and trying to find ways to also align with continuous integration, in my opinion. So those are, important things, and I think trying to make sure that that baseline becomes everyone can do it is really important.
So here's a distinction I've been trying to make, and you can tell me if I'm off base here, but I think part of the thing is we all come from hardware and we kind of stick to hardware. We think that what we're doing is more hardware related than it actually is in a way. So that there is something about like when you're writing real time code on an RT controller or whatever, you're down low, you're talking about hardware, that's more hardware restricted. But
Mhm.
once you get the data, once you've collected the data, everything from that point on, I am a firm believer is complete computer science. It's how do I get the data from point A to point B? How do I transport it across a network? How do I store it in a database? How do I store it in a file? How do I filter it? How do I generate reports? And all of that has absolutely zero to do with hardware. Like
Yeah.
it came from hardware, but once you get the data into the program and you're making decisions on it and you're doing things with it, that's all computer science. And a lot of the problems that we run into as LabVIEW programmers are problems that computer science has already solved, but we just because we don't have that computer science background, we haven't figured that out yet.
That's true. And honestly, I'll go back one step, which is to say, like when we were talking about value earlier, like most projects that are in LabVIEW and maybe most projects in general, but let's especially focus on the LabVIEW side, the the value of your entire application is the data you generate in almost every case. Like the data you're collecting that shows that your test worked, if it's a test and measurement kind of application, but if it's a control system, the data that you're using to demonstrate that you're maintaining control of that application, that process. Ultimately, the data is where your value comes, and like what you need to do with that data afterwards. Like that is where you can differentiate between sort of the amateur level of store it, not maybe not even store it, just display it and it's there and then it's gone, versus storage and then data processing, and then as you get into more and more professional use cases, you can get into more and more elaborate use cases of, how do I easily compare data to show it's in family or whatever. And that's where the sky is the limit. And that's where all the not just LabVIEW, but other tools can come in and be really effective. Because the once you got the data out of the hardware and into sort of, let's just call it the cloud, then literally the sky's the limit. You can do any number of things with that data if you know how to use it, and the more you are able to leverage that data and show, that's actually a really important way that you can deliver value.
So I do want to use that in a second to pivot somewhere else, but
Yeah,
before we do
sure,
that, I do want to ask a question,
sure.
and that is when we started talking about value and stuff, and I hear a lot of consultants talk about value, and I very rarely hear employees talk about that. Do you have any thoughts on that? Like, why is it just a different mindset, or
I think employees in organizations that don't already have kind of, I think this, I'll just put it this way. I think that for me, the value proposition and thinking about things in terms of their value literally evolved out of being a consultant. And I think that that helped for me to create a mindset around looking at every problem from what is the actual value of solving this problem, and like what kinds of things can I do to extract value from whatever I put my effort into, and how do I maximize that? And I think I don't think it's impossible to do that in any organization. Like, I don't think you have to be a consultant to do that, but I think it does help to have that mindset. Um, and once you have that mindset, you can train other people in your team or organization and focus them around what are the people that we're working with caring about. And maybe if you convert that word value to what do people care about, that kind of helps you create that equivalency within your organization. So for my team, for sure, I work really hard to help clarify to them what are the schedule things that are creating value, but also what are the stakeholders that we have. Usually, even with an internal deliverable, there's multiple groups that are stakeholders, and a lot of times they don't get um, recognized properly or incorporated properly. And I think that's actually another place where Agile the theory versus Agile the practice tend to diverge. Agile the theory, you really the like you want to have various stakeholders in your planning sessions and potentially in your daily stand-ups even, so that they're aware of the tracking of your actual progress. Excuse me. And also that they're aware of um, you know, transitions or pivots that you might have to make or decisions you might have to make based on what you're learning. And I think in a lot of cases, development groups tend to ignore that part and focus just on the developer side in the stand-up or whatever. And so they're a little more insular. And when you're insular like that, you don't get the benefit of the real, like, continuous feedback from your stakeholders saying, yes, you're like doing what I'm expecting. This is great. Or, hey, this isn't going the way we expected. Maybe we need to pivot our resources and our time and like deprioritize this thing because it's not taking us where we expected.
Yeah, I think part of that is like in larger organizations, the developers are more disconnected from the end users because there's more layers of people making
Yeah.
decisions in there. But
And,
also,
and honestly, they also, a lot of times, at least what I've seen, is that they don't ask for that feedback. Like they think it's not important to include them in that stand up or include them in their sprint planning or whatever. And they just focus on including them at the milestone level. And if you do that, you pretty much, you can get really bad results, is my experience.
yeah, I definitely think that is one of the places where Agile kind of goes off the rails a little bit.
Mhm.
Yeah, I like the ideas. The execution sometimes is not as great as it could be. I don't. I just think like for me as a consultant, the part of the reason I talk about value, I think part of it's like motivation. For me as a consultant, I'm always like the more value I can provide, the more I can charge, right?
Yep,
And
that's it. Yeah.
I like I like getting paid, and I like getting paid well. So like if I want to get paid well, I have to show that I'm delivering lots of value. So it's always kind of on my mind. Whereas an employee, yeah, you might be concerned about getting a raise or a promotion, but generally, like you get paid the same no matter what happens to the project. So that there's less motivation there, I think.
Yeah, and from my perspective, when I build teams and like who I hire and how I grow my team in specifically, I really try to get people that are engaged and committed and passionate about the problem, because then it also kind of creates that inherent desire to generate that value. I mean, it's like you're right, it doesn't necessarily translate in terms of um, trying to have them get a higher billable rate or whatever. But if you get people that are passionate about the outcome, then they're vested in a way that also makes them not just do the minimum amount of work needed.
Yeah, well, I think too, as a consultant, I'm primed to hear the word value, and I don't hear that a lot from employees. But there are things like you mentioned, like if you replace value with what do they care about,
Mhm.
employees do care about things,
Mhm.
and that is part of the value proposition. It's just they use different words.
Yep. And
So
consultants can get a bad rap too because it's like, oh, they're just here for, especially depending on the type of relationships that people have had with consultants. A lot of, you know, I'll just call it, in my mind, there's a difference between a contractor and a consultant. And contractor, you have a very specific task. You're basically outsourcing a task. I try not to use contractors. I do not really want contractors. Um, but consultants to me are people that are relationship oriented, value oriented. They're trying to understand what I care about and therefore deliver the values that I'm, also caring about. And they're, in my mind, more longevity oriented. They're not caring about the one specific project, but really the life cycle of the entire, program or project or whatever.
Yeah, the good analogy I've heard of that is like doctor versus waiter, right? Like a waiter just takes orders and just has a set of things that they do, and you just tell them what to do, and they go do it. And in my mind, that kind of equates more to the contractor type model,
Yep.
whereas the doctor's like, "Hey, tell me what your problems are. I'll go diagnose it," and it's more of like I'm looking out for your long-term health as opposed to just delivering something. So, so let's go back
Yep.
to something you said
Yeah, it's
earlier
not
about that.
clinician level. Yep.
Yeah, and about the data and collecting data. And a thought that I've always had is like as LabVIEW engineers, I feel like we leave a lot of value on the table because we do the data collection part and then we just turn the data over and we don't do any more. And so that's part of it. But the other thing I've been thinking about is you said the data is valuable, and there is value in the data, but I think more the bigger value is what decisions can you make from the data, and the data is like an integral part of that. You have to have the data in order to be able to to make the decision. But I think connecting the data to the decision, in my mind, is the true value.
That's a good point. Yeah. And what kind of decisions can that data enable you to make is another kind of related, I guess, a color area or whatever for that. I would say that one of the reasons I think traditionally that it's been hard for LabVIEW developers to kind of grow up that or move up that data chain in terms of like making sure the data can get used and consumed and create, and maximize the value of the data you collected. One of the limitations has been that the technical challenges to move it from a file to maybe thinking databases or others, and getting from databases to databases that also enable um, automated analysis and things of that nature to run. It was probably outside of the wheelhouse of most LabVIEW developers, and that I think has made it harder for the development community to fully leverage the data they've generated. I do think tools like SystemLink that NI has been maturing and is getting a lot more exciting, and easier to use and has more hooks out of the box to make it easier to get value. Those kinds of tools um, are a good stepping stone for getting closer to like an out of the box system or solution for managing data, and for managing test data specifically that's collected in sort of from a LabVIEW type application or a test stand type application environment. And I'm not currently, I'll be full disclosure, I'm not currently using SystemLink. I did use it when I was at Virgin Orbit. Um, I've not avoided it since then, but I've taken a slightly different path at Stratolaunch based on what resources and tools they had. Um, but I would say that like the concepts that SystemLink has fundamentally, and the way that that way that NI has implemented SystemLink is a really good way to help think about how data can be used in that broader organizational context, especially for orgs that don't have database administrators and don't have, the network and IT and other experience to just sort of get going out of the box quickly. Like if you want to find a way to elevate with very little um, effort from a design or architecture perspective, I think SystemLink is actually a real way to get going.
Yeah, I've seen people use System Link and
Not
Watts.
trying to make it a plug for NI.
Yeah. Well, yeah. So, yeah, there's also Watts, which is another one. And I've talked to the Watts people a little bit. So, small plug for them. I think my understanding the difference between System Link and Watts, and I don't know if you use Watts, but I think Watts is more for like production test, and it's very good at like just helping you set your limits and tolerances and things like that. for like tests that are repeated a lot. And I think System Link is really good at like more R&D type testing. That's kind of been my for the data analysis side of System Link. I think if I understand correctly, there's actually two sides to System Link, right? One is the data collection and analysis side, and the other side is managing the test systems and the hardware and being able to like push updates and things like that. Let me start by saying my understanding, and I am not a System Link expert, first of all. My understanding is System Link kind of has two parts, and one part is the data collection and analysis part. There's a data collection and analysis part that's like collect data from a bunch of places thrown in a database, and then like enable analysis with like DDM and other tools. And then there's also another half that is the managing systems and being able to push updates and manage what software is running on each system and those type of things. And my understanding of Watts, and this is basic, but I think Watts is more geared towards production tests, particularly I think they said electronic production tests. So if you're testing circuit boards and stuff, and
Sure.
it's like you're doing the same measurement over and over and over again. And you got thousands or millions of them, and you're looking at like the limits, and you're trying to set them at the right level and
Mhm.
that type of analysis. Whereas I think the NI system is maybe more flexible, more geared towards like R&D setups, where you've got a bunch of different test data, but maybe you're running different tests, and you're not necessarily doing the same test a million times in a row.
Yeah, I'm not sure actually. I think I can see System Link being able to support both, but I don't know that it's focused on that. So yeah, that's an interesting thing. And I'll just say the way that for my current role, like the way with current job or whatever, we've actually just taken a totally different approach and done a roll your own solution, which has been an interesting experience and experiment, I guess, that's going on right now. And so it's a live experiment of trying to streamline and simplify what our data pipeline kind of process could look like, and creating an ecosystem that is scalable, flexible, but also based on open source tools.
Yeah, well, I think that's another important question, right? Is if you need these types of services, is it better to create your own out of open source tools or proprietary tools, or is it better to go with one of the ones off the shelf? And my general feel, and always the buy versus build thing, is if the thing you buy does what you need it right out of the box and you can get up and running quickly, and you're okay with turning over that level of control, then that's the easy solution. And then if things change and you need to move later, great. Because I feel like there's a maintenance cost associated with building your own that people often neglect.
Oh yeah, building your own is not necessarily cheaper. If you're doing it to build your own to make it cheaper, you're probably doing it for the wrong reasons. And
Yeah,
you probably should reconsider, to be totally honest.
yeah.
Um,
I
I
think
think
to build your own,
flexibility and other things matter. Sorry, go ahead.
oh, it's just gonna say in my mind to build your own. The two reasons are one, we want that level of control because we don't trust the company that owns whatever that they're not going to go away or whatever,
Mhm.
and or we need to like self-host it or something like that, and it's just not out there. Or you need some specific feature and they just don't have it.
Right.
Yeah,
Yep, I think that's true. I think the other aspect of it that I've learned is that people really underestimate what it really takes to build products. So, like, if you want to do it in-house and build your own stack or whatever, you're basically deciding that, hey, I want to build a product. And if you're not really committed to building a product, then you should just buy the product like that, in almost every case. So I happened to have in this project and whatever, I had enough knowledge about what I wanted, and also of where the boundaries were that were going to be pain points, that the build versus buy kind of equation um tilted slightly towards build. And I'll be honest, like the buy equation, if I look at total cost of ownership, it's you're not talking about like, oh, I saved 50% or whatever it is. It's really like probably a much smaller percentage of savings in terms of dollars, but what we're, you know, the biggest benefit, I guess, or bang for the buck in our case has been by owning that stack, we have a lot more control of how we can use it. And so that's been our, the trade space.
Well, on the buy versus build, you did mention products. There is an interesting thing to explore, and I'm not suggesting this works in very few cases. But there's the whole idea of like Amazon needed all these services, so they built all these internal services. They built them as a product, and then they were able to sell them as AWS.
Yep.
So depending on what you're doing, right? If you're doing something, you're like, hey, there's a hole in the market here. Nobody's filling it. We can fill it internally for our own thing. There is the potential to turn it into a product. But again, though, to your point, running a product is a whole different business. You need the support, you need the right, you need to constantly be innovating and so
Yeah.
that's always it's worth thinking about that and having that in the back of your mind, but like realizing that also that's changing your business model and it's also opening up a whole can of worms.
The skill sets that you need are very diverse. You've got IT type skill sets, you've got database, you've got software skill sets for, and web integrations and possibly like front type developers. So there's so many different things that you need, and back-end developers that when you build your own system for this kind of like data type system, you're not talking about a small investment, and that's why that build versus buy, if you can buy it, you should do it because you'll go faster, you'll get there quicker.
Yeah. Well, and also if you're thinking, taking a step back to that product thing, like if you're thinking, oh, I'll take this thing and productize it, then not only do you need all those other people, but you also then need sales and marketing and support,
Yep.
which is all there.
Yep.
Oh,
If you actually end up doing that, and legal, you need to figure out like what parts you are actually able to sell potentially, depending on the license agreements of the source tools that you
yeah,
start from. And it's a bigger can of worms. And my recommendation for most people is just, you know,
avoid it. Yeah,
adopt a product that meets your needs and let their expertise minimize what you need to do in-house.
yeah. No,
Sure, no, you're not a data company, but you do need the data.
yeah. So speaking of data, there's a lot of talk about doing data analysis in Python, and there's also a lot of overlapping talk about using Python for test and measurement. What have you seen in that space?
So, like my team is doing exactly that. We have a mix. We're using LabVIEW and Python and other tools as well, but mostly LabVIEW Python. And the LabVIEW side is almost 100% oriented around the data collection side, automating instrumentation so we can collect data from hardware and taking that data and saving it into, to be honest, in our case right now, mostly just going into files like TDMS files. But then we're also using Python for a couple of different things. We're using Python to orchestrate our application. So we're using in our LabVIEW code, we're embedding, I think it's the JKI Python bridge package, and that basically exposes an API to our application code in LabVIEW from Python, so we can do things like complicated thermal sequences, just running it from a Python script, where we have to orchestrate different test stations and things like that and have them running in parallel, and the orchestrator can be basically our Python code of a simple
So
Python sequence.
I have
Mhm.
a question about that because I've seen and
Mhm.
I've inherited and used products where they have a sequencer written in LabVIEW and they have some sort of scripting language that they call to do stuff. Do you think it's easier or better to just use the JKI Python bridge and just do that scripting in Python, or is it better to have LabVIEW and create your own kind of couple command sequence
I mean, I
language?
will say this, I've done both things. And even right now I have kind of both things happening. So I can't say that um I understand where that boundary is. Um, what I've found in general is that every time you try to generate like, oh, I'm gonna just do a simple sequencer or whatever it is, and I'm gonna do that in LabVIEW with like a custom format or whatever, and not either use test stand or use Python or some other language to do that code. Um, Inevitably, you realize that you need more language features to get to your custom script because all of a sudden you're like, oh, I really do want to loop. and oh wait, I want to just loop conditionally, and oh wait, I needed, nest some sequences together or whatever it is, and all of a sudden you're like basically back to wow, like all those features are already supported in either test or Python or whatever. And so having, avoided that initial kind of reason was you end up going back to having to decide, well, do I want to maintain that decision or backtrack a bit? Anyway, so I'll just say like my experience has been that building your own sequencers carries um, the burden of eventually effectively developing your own scripting language.
Yeah, yeah,
Um,
exactly.
so anyway, the other aspect that we're using Python for though, so I kind of alluded to like our other architectural side. We've been using Python for processing our data files. So we've basically built up our own pipelining system where data gets transferred into a server and um, basically our pipeline gets kicked off and we use Python code typically to then do additional analysis on our data and the additional analysis and or like taking that data and shoving it into databases or whatever as part of a post-processing step. So we're doing a lot of things like that. And that code, at least for our org, is right now typically in Python, and it's working out because our, test developers, our test engineers are very, comfortable with Python. But I also have, other groups that I can leverage, like our software development team or IT or whoever, and they've also got experience with Python. And then the other advantage is that the just general ecosystem in Python right now it's where most of the advancements in sort of data engineering have gone, whether that's, machine learning or whatever.
Yeah, apparently there's a lot of machine learning and vision and other applications and stuff that happen in Python that are PyTorch, I think, and there's a bunch of other
Right.
TensorFlow and a bunch of other things that are written in Python.
Yeah, exactly. So, I feel like Python, at least for my experience so far, has been a very go with the flow mentality. Like, yes, we've collected the data, we can then shove it into databases or whatever, and then or use Python to continue to process that data. Um, I'll just say, like, from my experience, another area that has been very common in the last couple of jobs I've worked on, or like locations I've worked in, whatever, is using Jupyter type notebooks. So um, they're the Jupyter is basically like, what do they call it? IPython. It's this interactive Python framework, and um, engineers, it basically enables you to have Python with sort of like a GUI and a reporting kind of structure built in. And so it's very natural for engineers to want to use a tool like that. And we've been able to use other automation hooks to basically um, automate executing Jupyter notebooks and leveraging that. Um, I first got exposed to I was using Jupyter notebooks when I was at Virgin Orbit. Our group was using them. That's where I first got exposed to that in a sort of broader adoption kind of where it was broadly adopted within the organization. Um, and I'll say one of the really exciting presentations and like experiences I'll say that I had was going to NI Week. That's the last NI Week before I think it converted to NI Connect. And watching a presentation by Soliton on using um, Jupyter notebooks with a machine learning process with LabVIEW, and it's actually already well documented. There's a blog post on Soliton's website you can go find, talking about how to use System Link with Jupyter notebooks, and that was pretty exciting to me. And I'm still kind of, continuously growing my capabilities around concepts that I learned at that NI week that I thought, carried forward to me to this day.
Yeah, Soliton actually, they do a lot of good work. I don't think they're as well known in the US as they probably should be because I've seen a lot of cool stuff that they've put out. So,
Yeah.
love
Yeah.
what they do.
And in that area, at least I haven't seen anybody publish more detailed or better kind of examples of how to make that work. So they've done a very good job of creating a roadmap and open sourcing it. So if you
Yeah, they've
haven't,
also done some cool stuff with testing and GUI testing. Their SLL Drona stuff is quite good.
oh
I
yeah,
haven't used
I've
it. I've
not
just kind of
followed.
seen the demos, but that's been something that I've kind of struggled with is wanting to do some kind of like GUI level testing, and I find it really hard.
Yeah,
Speaking
it
of
is really
testing,
hard.
so I
Mm.
do want to change just
Mhm.
past just a little bit. You had mentioned unit testing.
Sure.
You had a lot of involvement in Karaya when it was being developed, right?
Actually, no. So, well, I had some, but not really. So, I actually worked really hard on VI Tester, actually. So that was the precursor to Karaya. When I was at JKI, at the time, there was no unit test framework, period, that existed in the NI community or ecosystem. Um, and At JKI, we had realized that that was a gap that we wanted to try to, be thought leaders in. And we used, man, I think it's PyUnit and not PyTest. I'm pretty sure it's PyUnit as a sort of a reference design for creating a LabVIEW based unit test framework. And that's what we created, which was but it was, VI tester. And we didn't realize this until we were very far into our development cycle, but NI was also working on the NI unit test framework, which was a vector-based test framework for unit testing LabVIEW code, VI. And so we ended up inadvertently in a mini competition with NI over kind of getting it released and also like figuring out adoption and whatnot. And I'm still proud of like what VI Tester does and what it was able to accomplish, but I've also moved on and I use Karaya when I do unit testing now. So
Yeah.
all things, you can take lessons learned and apply them. And the main author for the original Karaya was Tomi Mila, and he's you know, no longer at JKI either, but he thought that the ideas behind VI Tester were good, but that it was a bit too cumbersome and complicated for most people to use. So he wanted to kind of do it with a different mentality. And Karaya's technically an assertion test framework and not, so it's kind of a different style of testing than the architecture behind VI Tester. But I find it to be really valuable. And to be honest, I'm using Karaya and not VI Tester in all of the places where I do unit testing now.
Yeah, I used to use VI Tester. I quite like it. It's just it has not been maintained very much lately. It's kind of
Yeah.
fallen off the radar. And then Karai is kind of the new kid on the block. I've moved
Hmm.
now. I oscillate back and forth between Karaya and LUnit, which is a newer version
Hmm.
of VI Tester. It's much more class-based, kind of like VI Tester, whereas Karaya is more freeform. Kind of the equivalent would be like unit test in Python is more like or Python is more related to the original JKIVI tester, and then what is the new one? PyTest. Yeah, PyTest is the more freeform thing.
Similar to
It's kind of more free.
Karaya. Yep.
Gives you a little bit more freedom,
Yeah.
which is funny because I like PyTest when I'm in Python for some reason, and when I'm in LabVIEW, I like more of the unit test VI tester style. So I don't know. I don't know why. It's just weird. Um,
Yeah, no, I mean, I think it's important to, find the tools that work best for your use cases and not feel like you have to use the hammer every time. So, I mean, I'm not offended if people evolve and also products and in general, like tools, adoption matters, maintenance matters. Like if a company builds a tool, like let's just say VI Tester, and then another tool comes along and VI Tester stops getting maintained for whatever reason or whatever, then people will move on and find the thing that is getting effort put into it. And so I don't. I don't have any
Yeah.
real philosophical qualms with that.
Yeah. But it's weird though, as a consultant, it's kind of hard for me to standardize on any one tool because I work with so many different teams and every team, like I can't
Mhm.
standardize on After Framework or DQMH very easily because I deal with team. Like I guess if you only do new projects or if you just do turnkey
Mhm.
stuff, it's one thing. But if you're inheriting projects from other companies, like you just get what you get sometimes. And it's like, oh, they're using JKI State Machine. Okay, great. Well, I guess I gotta go learn that now to go work on this project.
Sure.
So
Yeah, and actually, I'll say that the biggest risk, like a lot of one of the places where we talked about risk earlier, um, if the tools get developed but then stop getting maintained, then they can stop working and become broken. And so, as a consultant, I can understand like if you don't want to adopt or leverage a certain, you know, whatever the product of the year happens to be, because over time that may no longer be favored, and now all of a sudden you're stuck trying to maintain code that the actual underlying code isn't getting upgraded to support the new versions of LabVIEW or whatever it might be, and now you're kind of like stuck with your personal reputation or your company's reputation staked against stuff that you don't have control over. So it is a complicated problem. I think that that's where for most of those tools, the fact that they're open source is really helpful, because if they're not open source and you also depend on them, and then they do get neglected for whatever reason, then you're really like you're stuck.
that's why I'm very reluctant to depend on closed source things. One of the few closed source things that I do depend on is VIPM. So hopefully that doesn't go
Mhm.
away anytime soon.
I
Yeah,
think everybody does now, so yeah.
yeah, it's pretty integral part of the thing. But it is worth remembering that it is closed source and like so
And LabVIEW is too. So it's like, well,
these two.
there's a
I mean, sometimes, but yeah, if I have a choice, I generally prefer open source just because, to your point, like if people stop maintaining it, there's always the option of me maintaining it. I
yeah.
don't really want to take that on for anything, but if somebody's willing to pay me enough money to keep it going, then maybe. You
Yeah,
project
yeah.
depends on my tester, and they're just like, we're not changing, and here's a bunch of money to go fix it. Sure. So if anybody's
Right.
out there and uses VI Tester and wants somebody to upgrade it, come pay me. I'll go upgrade it. But
Yeah.
I'd probably recommend you move on to something else because it's just yeah.
Yeah, yeah, exactly. Like
And if
um
you are using VI Tester, switching to LUnit is actually quite easy, so it's not too
well,
bad.
and actually like, one of the other really I'll call it challenges of all of engineering in general and of product management and product lifecycle management. If your product life cycle is long, like it's one thing if your product life cycle is, short and you're going to be in and out, and the entire project and entire value of that product is going to be, 1 or 2 or 3 years, and then it's going to get replaced with something new anyway. But if you have projects that you want to maintain for 5 or more years, especially, then it gets complicated. The tools, the software, the hardware, even that you want to run on, may not exist anymore, and you have to really think about complete like platform management and product management so that you have sparing and software considerations. Like how are you going to deal with, making sure that the operating system you care about still exists and hasn't been updated in a way that's no longer compatible with what you need, and the hardware level, same thing, and software and licenses and tools. It gets harder the longer that window needs to be static. If it's five,
Especially too nowadays, if you throw software
mm,
security into that
yep,
mix, that really changes things because software security says, "Oh, you need to be running the latest and greatest patches," and it's like, well, okay, but does the vendor support those? And what do you do when you run into incompatibilities? And yeah,
right. And for aerospace type projects, especially like traditional aerospace, you've got like 10 years as a minimum probably life cycle for some of the products. And like, and to be totally blunt, like if I was to buy, let's just say, some random NI card right now to put in like a PXI or a CRIO or whatever it is, whatever form factor you can pick the form factor. If I pick a module, the chance that that module is still being sold in 10 years from now is probably, depends on what the functionality is and whatever, but it's probably low chance that it's still going to exist in that kind of a time scale. So the longer that life cycle needs to be, the harder your product management
yeah.
life cycle kind of challenges become.
Well, even in the commercial space, I think that's changing because the EU, I think, is having lots of laws around like you have to support things for a certain number of years. Because it's kind of disappointing when you buy a new electronic device and it just stops working after a couple of years, and it's like, well, it should continue working, but they no longer support it, and so I think that they're trying to get into that. And part of the challenge is like there are challenges in supporting stuff that long, and then also the incentives are don't make it last that long, make them buy a new thing in 2 or 3 years. So it's like these competing priorities.
Yeah, but and to be fair to suppliers, to like to NI or to anybody else,
Yeah,
like the components that you made the bomb for that part might not
yeah,
exist.
yeah, exactly. Yeah,
So
yeah,
they have to rev it anyway. So like if they're gonna have to rev it and then they want to make it better because it makes it, a better niche or a better fit to the market, that's great. But now all of a sudden the thing that you were, trying to do configuration management on and all this other stuff is like out the window, or you have to do regression or whatever it might be.
yeah,
So anyway, it's just one of these constant
yeah.
challenges, I
Yeah,
think.
it's easy to call it all planned obsolescence, but there are real challenges in maintaining stuff for that long as well. So
Yeah. And if you're buying stuff and it's like sort of late in the life cycle of that product, you also have, I mean, NI does a good job, honestly, of at least flagging it on their website. Hey, this thing is slated for obsolescence. You might want to use a different product. At least that's there, which is really helpful. But uh, you know, you can't you can't guarantee anything. And some products also just naturally become casualties of business cycles. So you can look at any number of, soft motion or other type of products that were really, heavily invested in and maybe no longer are. And so I'm not sure if that's one. I just am pretty sure that is one.
yeah, yeah, no, definitely. And there's also like the consideration of like, okay, well, we'll just buy a whole bunch of spares. Well, that's great, but what are you doing with those spares? How are you storing them? And sometimes like they just decay, and after a while they're no good anyway. So if you
Right.
just like sit it on a shelf, that's may or may not work. You might need climate control and other things to make sure that they still work.
Yeah, the other area where I found like, and I don't know, this is kind of segueing from segues, but the other area where I found challenges in the past is that if you buy like an overly specialized device from a generic type of company, and I'm just going to use NI as an example again, but like, let's say I buy a very specific motion control type of system from NI, but NI is more generic and motion control is just one area that they care about. Um, A, I have to deal with the product lifecycle problems, but B, like if something goes wrong later and I'm looking for a spare or whatever rental, I may not be able to find that like kind of backup option as easily as if I had just, picked a company that's more focused on motion control that has like heck a legacy of motion control, support and that's their main company focus. And I'm using motion control as if I have a recent experience with that. I'm not actually doing anything with motion control right now, but it's just kind of
Yeah. Well, I will say I was at a user group meeting last night, and Eli was there, and yeah, the topic of motion control came up, and they were pretty much like, "Yeah, that's gone."
yeah,
Vision, though, apparently that is still around, and they're still investing in that because I know Vision was one of those ones that's like kind of like motion control. Like, are they going to hang out or not? And apparently they're. I mean, I don't know what their exact plans are, so and I don't want to put any words in Eli's mouth, but Vision is sticking around. Motion,
okay,
yeah, go find somebody else.
right.
Plug though, John Woo of Tenant Technologies basically has drop-in replacement for the old NI motion stuff. So if you're like
Well,
looking for that, go talk to him. Free
cool.
plug, John. You're welcome.
I mean, these things are I'm really using motion as just a subcategory of like any number of these like mini verticals or mini
Uh,
segments that
PDA stuff and the phone stuff, right?
yeah.
They had the LabVIEW mobile, right, for a little while.
Oh yeah. I mean, I still remember how excited I was when my dad had come back from a conference and had received an HP like handheld device that was running Windows CE and he gave it to me because he didn't want to use it. And I mean, this was like decades and decades and decades ago, but I remember that that was really cool and exciting. And I don't know, does Windows CE still exist? I don't know.
I think that went away. But
Yep, I'm pretty sure.
I do have one last question I like to ask people, and that is, can you tell me about an experiment that you tried that maybe didn't turn out the way you thought it would, and what you learned about from it.
Yep, I've been thinking about this one. So I have I'll just say in general, my entire career is an experiment, and every single day and every single like aspect of what I'm doing right now, like I can think of all of these things that are happening, and I'm always looking for like how am I going to influence the results, or if I'm not going to influence the results, like what is the data telling me from the test I'm doing or the experiment that I'm running, and how can I use that to make better decisions for the future? Um, One of them that is kind of a weird but has stuck with me and is I'll just say a career level learning experience was um, quite a long time ago. I worked in another aerospace company doing work, and in that group, I helped build a test framework that I didn't design it from scratch, but I helped build on top of it and augment it. Um, and it was designed so that we could it was running with LabVIEW and test stand and test framework for basically like aerospace type of application. And we had both, you know, open and also closed customers. So in a classified kind of environment, the framework had to be able to transfer down and run in that world. And one of the kind of late requirements that came to us was that we needed to have configuration management of the entire system um, in such a way that we could show quantitatively that we had run our code with no changes. And the easy answer, right? Oh, and kind of related, our entire framework at the time was running, with test stand calling LabVIEW code from source. There wasn't like a executable or anything like that that we could use. So it was a lot of files that were basically just sitting on a server that we were running from. And then to make things a little bit more interesting, we also had a database, actually multiple databases that covered configuration and test results
Okay.
aspects of the data. And so we also needed to show configuration management of the database as well. Um, and so anyway, this was in a world where source code control for LabVIEW at least very, it was very early. Like there was no native anything for LabVIEW at that time. The 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 source code control system that we were piloting that we weren't actually using in our group was Tortoise CVS. So that's kind of like that's just giving you an idea of how long
Yeah,
ago this
yeah,
is
yeah.
in history kind of world. And so the experiment that I had to run, I got asked to find a way to create a configuration like verifier or whatever, like a CM type validation tool. And so my approach at the time was to basically find a way to checksum all our files and verify the checksums, and then work with our database administrators. We had a DBA, or actually had three DBAs working on the project because there was a lot of data and the open close nature and other stuff, and work with them to come up with a way to do some kind of a schema verification, and then also to do row level verification that our data hadn't changed. Um, it turned out that was really hard. And if you actually look up, especially the file side checksums, that's not as hard,
Yeah,
but
just
the database side was a lot more than I would have realized. And, initially would have thought, oh, this is going to be pretty easy. But it turned out to be really complicated. And if you actually go search for like database row level verification and schema verification and stuff, you'll find that it's still not trivial. Um,
yeah, yeah. I don't. I'm trying to think of the best, and the data and the configuration were all in the same database, right? That's probably part of it.
Yeah, so we had to, yeah, it was tricky. We had to, but
Except
in different
databases.
aspects. Yeah, and this database happened to be like an older version of an Oracle database, so it was also relatively heavy and complicated and, not not trivial. It was not a trivial thing to kind of set up. And so anyway, I think like from that, I worked really hard to get the technical part to where I thought it would work, and we would run the verification, and it would work. But then it turned out like making that scalable so that, okay, like here's an example of things that can go wrong. Um, a new project came along and they wanted a new column or whatever in the configuration database because we were missing some features. So they add a new configure, a new column with no data for our older project, but lots of data for the new project. So how do you
Which
make
is
sure
the
that the
same
schema
database.
verification, now you have to like you decide, okay, well, am I going to re-update the schema requirements and therefore like, create new checksums, or can I do something more elegant that can kind of verify that the columns that I care about haven't changed? Like, what do you actually do there? And like, how do you make that work? It turned into what was supposed to be a really short couple days or a week type project. It took a long time. Like it created effectively its own product and life cycle. And we finally got it where we felt pretty good about what we were getting able to cover. And then we started rolling it out to the stakeholders. This is again like pre before I was exposed to really agile as a process. So we finally, we as the development team wrote some code and got everything kind of working and demonstrated it to ourselves that we were making, meeting the objective. And then we pulled in this configuration management administrator, and immediately saw that we were going to have new challenges that we hadn't really counted on. So, for example, um, the CM administrator's vision wasn't very good, so we had used all default fonts and things like that, and there were lots of numbers she was supposed to record and whatnot, and she couldn't because they were too small. So we had to change the fonts and update basically like the accessibility was not a requirement when we started, but it turned out that it was actually a critical requirement that we had missed. Um, and then usability, like the CM team's config software skills and software experience was very, like, I'll just say like minimal. They didn't really know much about software at all, honestly. And so we had to revise and refactor and make it easier and easier for the actual use case of, you know, the CM person independently being able to audit that the application they're running meets all the requirements and hasn't changed and whatever. So that was one of my it was a learning experience because not only did we have the technical challenges that we did eventually, I think, come up with a good solution for, but that experience, and especially as we started going and migrating it to the other, closed area, and then getting reports back that said, "Oh, it didn't work this time," and well, how did it not work? And we couldn't really. It was really complicated because of the security requirements and having it air gapped and everything, and not being able to just know if they're running the right version of our code,
Yeah, yeah.
everything. It was very complicated. Um, and so the technical side was hard, but the user side was really also hard, um, and it took a lot more time than I had anticipated. And so I guess what I learned from that, and kind of talked about earlier, is making sure those other stakeholders are in the room and are part of that process early. I think I've definitely tried to carry that with me for forever.
Cool. Have you ever looked into the thing I like is the Agile Samurai has a well, they call it like a project inception deck. Have you looked at that?
Hmm. Okay, first of all, that book is one of my favorite books, and I recommend it, and I share that book with pretty much all of the new developers that come onto my team. Um, so yeah, I actually love that. The project conception deck is a really good section. The other one that I honestly in that book I find really valuable is the user stories, and talking about how to make good user stories and making it where you really find. I feel like they did just a fantastic job of like articulating like how to get details that can actually then become your, software, effectively software requirements and whatnot, project requirements. Um, I feel like that part gets really underutilized, and people just sort of gloss over what do users care about, and then you end up with code that nobody can use or people don't really care about. So I do find that that is the other area in that book that I've personally really um,
I
enjoyed.
feel like I kind of glossed over that, so I need to go back and look
I
at the
go back.
yeah,
Yeah,
I
go.
glossed over because I don't use it very much is the story points and the sizing part of it. So I
I
kind of
don't think I care about the story points at all, really. I
exactly, yeah,
found it to
kind of
be,
moved on from that. That's the
yeah,
one part that I tell people to just like kind of ignore. But the user story part I think is actually really useful and interesting.
yeah.
Yeah,
It's more about developing the story and asking good questions of your users so that you can fill in the blanks better, so that you have that understanding of what they care about. I think that's really going back to that whole value thing. That's a really good way for you to understand how to deliver value, which is basically to ask enough questions to get an understanding of what they care about. And I think that they do a really good job in that book. I feel like I'm talking that through.
cool. No, that's good. Yeah, I gotta go back and reread that specific section now.
Yeah.
Yeah, that's definitely one of the books I recommend a lot too. So
Yeah.
very much
It's
like it.
held up over time too, which is hard to do in a world where technology changes a lot. Processes, though, um, good processes tend to be stable.
Cool. All right. Well, thank you very much. It's been a great conversation.
Yeah, thank you. No, I really appreciate your time and like getting to do this and being, a part of this LabVIEW Experiment podcast. And honestly, like I think what you're doing for the community and sharing ideas and, creating these discussions is really, really invaluable.
Yeah, I think they're discussions that we should all be having. So it's good.
Awesome.
All
Yeah.
right. Thanks. That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment.